Hello, my name is Jensen, and today I'll be discussing the chemical effects and composition of acid rain. According to the U.S. Environmental Protection Agency, the term acid rain is used to describe deposition or deposited material that contains abnormally high amounts of nitric and sulfuric acids. Wet deposition, the most recognized type of acid rain, is formed when nitrogen and sulfur gases are produced, often through volcanic eruptions or factory emissions when burning fossil fuels. For this example, I'll be focusing on sulfur. When sulfur melts, then vaporizes, going through two phase changes, it in turn reacts with the oxygen in the environment. This combustion reaction results in a new gas, commonly known as sulfur dioxide, written as SO2. Let's stop and take a look at the equation for this first reaction. First, we have sulfur in a solid state, and oxygen, written as O2, the oxidant in our combustion reaction. These two reactants combine to produce a new product, sulfur dioxide, written as SO2. This gas is a major air pollutant, and in fact, over 18 million tons of it was released in the U.S. in 1999 alone. The second step of this acid rain formation process involves a product of the last reaction. Sulfur dioxide, as a gas, encounters the oxygen in the atmosphere. These two reactants combine to create a new gas, sulfur trioxide. This gas is gradually formed through an oxidation process. The equation for this next step has two reactants, sulfur dioxide, written as SO2, and oxygen, written as O2, obviously our oxidizing agent in this redox reaction. The oxidation of these two gases results in a new gaseous product, sulfur trioxide, written as SO3. Be sure to balance the reaction by adding a coefficient of 2 in front of sulfur dioxide and sulfur trioxide. We know that this reaction is an example of a redox reaction because the oxidation number of both sulfur compounds, sulfur dioxide and sulfur trioxide, increases from +4 to +6 as the reaction progresses. Thus, sulfur trioxide is being oxidized and is gradually produced as sulfur dioxide comes in contact with oxygen in the atmosphere. The third and final step of the formation of acid rain involves the product of our last reaction, sulfur trioxide. When this gas is released into the atmosphere, it encounters some wet weather clouds. These clouds house many water molecules, liquid molecules written as H2O. As these two reactants combine, they form a new product, sulfuric acid, written as H2SO4. This is acid rain, the damaging and corrosive pollutant that has plagued our environment for many years. And now let's review the equation for the final step of this acid rain formation. First, we have sulfur trioxide, a gas, added to water molecules, H2O, in liquid state. These two reactants combine to form our final product, sulfuric acid, written as H2SO4. This is an aqueous solution that is commonly known as acid rain, falling from our skies and having many damaging effects on the environment. Now, you might be wondering, why is this solution acidic? Well, to determine this, we can add the sulfuric acid, H2SO4, to water. This results in a dissociation of ions into H plus and SO4 minus ions. Thus, this dissociation increases the concentration of H plus ions in the overall solution, and as we know through the equation for pH, this higher concentration of H plus ions results in a lower, more acidic pH. Today in my experiment, I will be testing the pH of various solutions and making my own acid rain using sulfur. For this lab, I'll need 60 milliliters of tap water, 100 milliliters of tap water and hydrochloric acid, an acidic solution, 100 milliliters of tap water and sodium hydroxide, a basic solution, 250 milliliters of natural rainwater collected here in Portland, 250 milliliters of more tap water. Next, I'll add a couple drops of universal indicator to each of these solutions. Here I'm adding it to tap water. Next, to the acidic solution. As you can see, it turns a reddish color. Here I'm adding universal indicator to my basic solution with sodium hydroxide in it as it turns blue. Next, I add universal indicator to the natural rainwater I collected. And finally, I add a couple more drops of universal indicator to my last beaker of tap water, which will later become the acid rain. As you can see, the neutral solutions with a pH of 7 have a color of green with this universal indicator, while the acidic solution with a pH of under 7 is more reddish in color. And finally, the basic solution with a pH greater than 7 is bluish in color. The natural rainwater was a clearish green color, indicating that it has around a neutral pH. Finally, you'll need a crucible full of some solid sulfur and tongs. Next, light the Bunsen burner. Be sure you're doing this in the fume hood, as the gases produced can be quite dangerous. Unfortunately, in my experiment, we had a little bit of trouble heating the crucible, as it in fact broke in this process, but we made the best of it, and I continued with the experiment. So hold your crucible, or part of the crucible, with tongs inside your beaker that contains tap water and universal indicator. Swirl the beaker. As the gas of this sulfur is produced, as we've seen in our previous equations, it will produce sulfuric acid, turning the color of the tap water and universal indicator from a greenish neutral color to a reddish orange color as the pH decreases, indicating an acidic solution. Well, that's it. We made acid rain. I hope you now have more information about this dangerous pollutant. Thanks for watching.